Mount Pinatubo is an infrequently active stratovolcano in the Cabusilan Mountains on the island of Luzon, near the tripoint of the Philippine provinces of Zambales, Tarlac, and Pampanga. Before the volcanic activities of 1991, its eruptive history was unknown to most people. It was heavily eroded, inconspicuous and obscured from view. It was covered with dense forest which supported a population of several thousand indigenous people, the Aetas, who fled to the mountains during the Spanish conquest of the Philippines. The volcano's Plinian/Ultra-Plinian eruption on June 15, 1991 produced the second-largest terrestrial eruption of the 20th century after the 1912 eruption of Novarupta in the Alaska Peninsula. Complicating the eruption was the arrival of Typhoon Yunya, bringing a lethal mix of ash and rain. Successful predictions at the onset of the climactic eruption led to the evacuation of tens of thousands of people from the surrounding areas, saving many lives, but the surrounding areas were severely damaged by pyroclastic flows, ash deposits, and subsequently, by the lahars caused by rainwaters re-mobilizing earlier volcanic deposits, causing extensive destruction to infrastructure and changing the river systems months to years after the eruption. The effects of the eruption were felt worldwide. It ejected roughly 10 billion tons or 10 km3 of magma, and 20 million tons SO2, bringing vast quantities of minerals and metals to the surface environment. It injected more particulate into the stratosphere than any eruption since Krakatoa did in 1883. Over the following months, the aerosols formed a global layer of sulfuric acid haze. Global temperatures dropped by about 0.5 degrees Celsius in the years 1991-93, and ozone depletion temporarily increased substantially. Overview of the area. The volcano is 87 km northwest of Manila, the capital of the Philippines. Near Mount Pinatubo, the United States maintained two large military bases in the region. The U.S. naval base Subic Bay was 37 km south of Pinatubo, and the extent of Clark Air Base was just 14 km east of the volcano's summit. The volcano's location on Luzon places into immediate, unbroken proximity to nearly 50 million people. The Aetas, an indigenous group of people, the Aetas, had lived on the slopes of the volcano and in surrounding areas for several centuries, having fled the lowlands to escape persecution by the Spanish during their conquest of the Philippines, which began in 1565. They were a hunter-gatherer people who were extremely successful and surviving in the dense jungles of the area. These people also grew some staple crops such as wheat, barley, rice and raised animals. In total, about 30,000 people lived on the flanks of the volcano, and about 25 established barangays and other small settlements like Tarlac village and Maraglu. The dense jungle covering most of the mountain and surrounding peaks supported the hunter-gathering Aetas, while on the surrounding flatter areas, the abundant rainfall of almost 4 meters annually, provided by the monsoon climate and the fertile volcanic soils, provided good conditions for agriculture. History. Mount Pinatubo's summit before the 1991 eruption was 1,745 am above sea level, only about 600 am above nearby plains, and only about 200 am higher than surrounding peaks, which largely obscured it from view. It is part of a chain of volcanoes which lie along the western side of the edge of the island of Luzon called the Zambales Mountains. Pinatubo belongs to the Cabusilan Mountains, the central range of the Zambales Mountains, which consists of Mount Cuadrado, Mount Negron, Mount Mataba and Mount Pinatubo. They are subduction volcanoes, formed by the Eurasian plate sliding under the Philippine mobile belt along the Manila Trench to the west. Mount Pinatubo and the other volcanoes on this volcanic belt arise due to magma occlusion from this subduction plate boundary. Pinatubo is flanked on the west by the Zambales Ophiolite Complex, which is an easterly dipping section of Eocene oceanic crust uplifted during the late Oligocene. The Tarlac Formation north, east and southeast of Pinatubo consists of marine, non-marine and volcaniclastic sediments formed in the late Miocene and Pliocene. The most recent study of Mount Pinatubo before the activities of 1991 was the overall geological study in 1983 and 1984 made by F.G. Delfin for the Philippine National Oil Company as part of the surface investigations of the area before exploratory drilling and well testing for geothermal energy sources in 1988 to 1990. He recognized two life histories of the mountain, which he classified as ancestral and modern Pinatubo. Ancestral Pinatubo. Activity of ancestral Pinatubo seems to have begun about 1.1 million years ago and probably ended tens of thousands or more before the birth of modern Pinatubo. Much of the rugged land around the present volcano consists of remnants of ancestral Pinatubo. It was an andesite and dacite stratovolcano whose eruptive activity was much less explosive than modern Pinatubo. Its center was roughly where the current volcano is. The projected height of the mountain is up to 2,300 am, 43 miles above sea level if it was a lone peak, based on profile fitting to the remaining lower slopes, or lower if it had more than one peak. The old volcano is exposed in the walls of an old 3.5 km, a 4.5 km wide caldera, referred to as Typhoon caldera by Delfin. Some of the nearby peaks are the remnants of ancestral Pinatubo, left behind when the softer parts of the old mountain slopes were eroded by weathering. Ancestral Pinatubo is a volcano with modern Pinatubo as the new cone. Its remaining caldera rim includes Mount Donald McDonald, forming the southeast rim, and Mount Typhoon, the longer north-to-northeast rim, after which the caldera was named. Mount Durst, to the east, is part of the dip slope of the ancestral Pinatubo. Several mountains near modern Pinatubo are old satellite vents of ancestral Pinatubo, forming volcanic plugs and lava domes. These satellite vents were probably active around the same time as the ancestral volcano and include the domes of Mount Negron, Mount Cuadrado, Mount Metaba, and the Bituin and Tapingo plugs. Modern Pinatubo, 33,000 BC, after a long period of dormancy, modern Pinatubo was born in Pinatubo's cataclysmic and most explosive eruption, estimated to be 5 times larger than the 1991 eruption. It deposited all around the mountain up to 25 km3 of pyroclastic flow material up to 100 meters thick. The total volume of volcanic material ejected during the eruption is unknown. The removal of so much material from the underlying magma chamber caused the Typhoon caldera. The eruptive period started by the eruption is referred to by Delfin as the Ainararo eruptive period, named after a village that was destroyed in the 1991 eruption. Later eruptions of modern Pinatubo occurred episodically and lasted for periods much shorter than the repose intervals between them. Subsequent eruptions and eruptive period occurred about 15,000 BC, 7,000 BC. Its eruptions were as energetic, if not as voluminous as the Ainararo eruptions. 4000 to 3000 BC. This and the Maronot period's eruptions were smaller than the Ainararo eruption but about 2 to 3 times as big as that of 1991 based on the pyroclastic flow run-out distances and depths of valley filling. 1900 to 300 BC, 1500 AD. Its eruptions were roughly the same size as those of 1991. Each of these eruptions seems to have been very large, ejecting more than 10 km³ of material and covering large parts of the surrounding areas with pyroclastic flow deposits. Some eruptive periods have lasted decades and perhaps as much as several centuries and might appear to include multiple large explosive eruptions. The maximum size of eruptions in each eruptive period though have been getting smaller through the greater than 35,000-year history of modern Pinatubo, but this might be an artifact of erosion and burial of older deposits. The oldest eruption of modern Pinatubo, Ainararo, was also its largest. The 1991 eruption was among the smallest documented in its geologic record. The volcano has never grown very large between eruptions, because it produces mostly unwelded, easily erodible deposits, and periodically destroys the viscous domes that fill its vents. After the Bwag eruption, the volcano lay dormant, its slopes becoming completely covered in dense rainforest and eroded into gullies and ravines. The 500-year repose though between the Bwag and present eruptive periods is among the shorter repose periods recognized in its geologic history. possible precursor in 1990. On July 16, 1990, the major 1990 Luzon earthquake of magnitude 7.7 struck central Luzon. This was the largest earthquake recorded in 1990, comparable in size to the 1906 San Francisco earthquake and the 2008 Sichuan earthquake. Its epicenter was in the municipality of Rizal, Nueva Ecija, about 100 km northeast of Pinatubo, and faulted northwest-southeast through 3 provinces. It also followed the Philippine fault system west as far as Baguio City, which was devastated, and is located about 80 kilometers north-northeast of Pinatubo, leading volcanologists to speculate that it might ultimately have triggered the 1991 eruption, although this is impossible to prove conclusively. 2 weeks after the earthquake, local residents reported steam coming from the volcano, but scientists who visited the mountain in response found only small landslides rather than any eruptive activity. 1991 activities leading to the eruption. On March 15, 1991, a succession of earthquakes were felt by villagers on the northwestern side of the volcano. Further earthquakes of increasing intensity were felt over the next 2 weeks, and it became clear some kind of volcanic activity was likely. On April 2, the volcano awoke, with phreatic eruptions occurring near the summit along a 1.5 km long fissure. Over the next few weeks, small eruptions continued, dusting the surrounding areas with volcanic ash. Seismographs recorded hundreds of small earthquakes every day. Scientists immediately installed monitoring equipment and analyzed the volcano for clues as to its previous eruptive history. Radiocarbon dating of charcoal found in old volcanic deposits revealed the last 3 major explosive eruption periods in recent millennia, about 5,500, 3,500 and 500 years ago. Geological mapping showed that much of the surrounding plains were formed by lahar deposits from previous eruptions. Volcanic activity increased throughout May. Measurements of sulfur dioxide emissions showed a rapid increase from 500 AT per day by May 13 to 5,000 AT per day by May 28. This implied that there was a rising column of fresh magma beneath the volcano. After May 28, the amount of SO2 being emitted decreased substantially, raising fears that the degassing of the magma had been blocked somehow, leading to a pressure buildup in the magma chamber and a high likelihood of explosive eruptions. The first magmatic eruptions occurred on June 3, and the first large explosion on June 7 generated an ash column 7 km high. The Philippine Institute of Volcanology and Seismology issued a warning indicating the possibility of a major eruption within 2 weeks. Evacuations. Given all the signs that a very large eruption was imminent, the Volca assisted by the U.S. Geological Survey worked to convince local inhabitants of the severity of the threat. A false warning might have led to cynicism about any later warnings, but delaying a warning until an eruption began might lead to thousands of deaths, so the volcanologists were under some pressure to deliver a timely and accurate assessment of the volcanic risk. 3 successive evacuation zones were defined, the innermost containing everything within 10 km of the volcano's summit, the second extending from 10 to 20 km from the summit, and the third extending from 20 to 40 km from the summit. The 10 km and 10 to 20 km zones had a total population of about 40,000, while some 331,000 people lived in the 20 to 40 km zone. 5 stages of volcanic alert were defined, from Level 1 up to Level 5. Daily alerts were issued stating the alert level and associated danger area, and the information was announced in major national and local newspapers, on radio and television stations, by non-governmental organizations, and directly to the endangered inhabitants. Many of the Aetas who lived on the slopes of the volcano left their villages of their own volition when the first explosions began in April, gathering in a village about 12 kilometers from the summit. They moved to increasingly distant villages as the eruptions escalated, some Aetas moving up to 9 times in the 2 months preceding the cataclysmic eruption. The first formal evacuations were ordered from the 10 km zone on April 7. Evacuation of the 10 to 20 km zone was ordered when a Level 4 alert was issued on June 7. A Level 5 alert triggered evacuation of the 20-40 km zone on June 13, and in all some 60,000 people had left the area within 30 kilometers of the volcano before June 15. Most people temporarily relocated to Manila and Quezon City, with some 30,000 using the Amaranto Velodrome in Quezon City as an evacuee camp. 1991 eruption, the second largest volcanic eruption of the 20th century, and by far the largest eruption to affect a densely populated area, occurred at Mount Pinatubo in the Philippines on June 15, 1991. The eruption produced high-speed avalanches of hot ash and gas, giant mud flows, and a cloud of volcanic ash hundreds of miles across. Climactic eruption build-up. In early June, tiltmeter measurements had shown that the volcano was inflating, evidently due to growing amounts of magma filling the reservoir beneath the summit. At the same time, seismic activity, previously concentrated at a depth of a few kilometers below a point about 5 kilometers northwest of the summit, shifted to shallow depths just below the summit. On June 7, the first magmatic eruptions took place with the formation of a lava dome at the summit of the volcano. The dome grew substantially over the next 5 days, reaching a maximum diameter of about 200 am and a height of 40 am. Timely forecasts of an eruption by scientists from the Philippine Institute of Volcanology and Seismology and the U.S. Geological Survey enabled people living near the volcano to evacuate to safer distances, saving at least 5,000 lives. A small explosion at 3:41 on June 12 marked the beginning of a new, more violent phase of the eruption. A few hours later the same day, large explosions lasting about half an hour generated an eruption column which quickly reached heights of over 19 kilometers, and which generated pyroclastic flows extending up to 4 km from the summit in some river valleys. 14 hours later, a 15-minute eruption hurled ash to heights of 24 km. Friction in the uprushing ash column generated abundant lightning. A third large eruption began at 8:41 on June 13, after an intense swarm of small earthquakes over the previous 2 hours. It lasted about 5 minutes, and the eruption column once again reached 24 km. After 3 hours of quiet, seismic activity began, growing more and more intense over the next 24 hours, until a 3-minute eruption generated a 21 km high eruption column at 13:09 on June 14. The fall from these 4 large eruptions was extensive to the southwest of the volcano. 2 hours after the last of these 4 explosions, a series of eruptions began which lasted for the next 24 hours, and which saw the production of much larger pyroclastic flows and surges which traveled several kilometers down river valleys on the flanks of the volcano. Dacite was the igneous rock making up the tufa in these eruptions and in the following climactic event. The most abundant phenocryst minerals were hornblende and plagioclase, but an unusual phenocryst mineral was also present, the calcium sulfate, and hydrite. The dacite magma was more oxidized than most magmas, and the sulfur-rich nature of the eruption was probably causally related to the redox state. The climactic eruption, all the seismographs at Clark Air Base had been rendered inoperative by 14:30 on June 15, mostly by pyroclastic density currents. Intense atmospheric pressure variation was also recorded. On the same day, Typhoon Yunya, locally named as Diding, struck the island, passing about 75 km north of the volcano. The typhoon rains made seeing the eruption impossible, but measurements showed that ash was ejected to 34 km high by the most violent phase of the eruption, which lasted about 3 hours. Pyroclastic flows poured from the summit, reaching as far as 16 km away from it. Typhoon rains mixed with the ash deposits caused massive lahars. The ash cloud from the volcano covered an area of some 125,000 km2, bringing total darkness to much of central Luzon. Almost all of the island received some ash fall, which formed a heavy, rain-saturated snow-like blanket. Tufa fell over most of the South China Sea and ashfall was recorded as far away as Vietnam, Cambodia and Malaysia. 12 days after the first magmatic eruptions of June 3, on June 15, 1991, by about 22:30, and about 9 hours after the onset of the most recent climactic phase, atmospheric pressure waves had decreased to the pre-eruption levels. No seismic records were available at this time, but volcanologists believe 2230 marked the end of the climactic eruption. Vast quantities of minerals and metals were brought to the surface. Overall, introduced to the surface environment, was an estimated 800,000 AT of zinc, 600,000 AT of copper, 550,000 AT of chromium, 300,000 AT of nickel, and massive amounts of toxic heavy metals such as 100,000 AT of lead, 10,000 AT of arsenic, 1,000 AT of cadmium, and 800 AT of mercury. The eruption effects on aircraft: at least 16 commercial aircraft made damaging encounters while flying with the ash cloud ejected by the June 15 eruption, as well as others on the ground. The encounters caused loss of power to one engine on each of 2 aircraft. 10 engines were damaged and replaced, including all 4 engines of one jumbo jet. Longer-term damage to aircraft and engines was reported, including accumulation of sulfate deposits on engines. The eruption also irreparably damaged the Philippine Air Force's recently retired fleet of Vought F-8s, as these were in open storage at Basa Air Base at the time. Aftermath of the 1991 eruption. Explosivity of the eruption: the June 15 eruption had a volcanic explosivity index of 6, and came some 450–500 years after the volcano's last known eruptive activity. The eruption ejected about 10 km3 of material, making it the largest eruption since that of Novarupta in 1912 and some 10 times larger than the 1980 eruption of Mount St. Helens. Ejected material such as tufa fallout and pyroclastic flow deposits are much less dense than magma, and the volume of ejected material was equivalent to about 4 km3 of unerupted material. The former summit of the volcano was obliterated and replaced by a caldera 2.5 km wide. The highest point on the caldera rim now stood 1,485 am above sea level, some 260 am lower than the pre-eruption summit. Death toll: A reported 847 people were killed by the eruption, mostly by roofs collapsing under the weight of accumulated wet ash, a hazard amplified by the simultaneous arrival of Typhoon Yunya. The evacuation in the days preceding the eruption certainly saved tens of thousands of lives, and has been hailed as a great success for volcanology and eruption prediction. However, damage to healthcare facilities and the spread of illnesses in relocation facilities due to poor sanitation, led to rising death tolls in the months after the eruption. After the eruption, about 500,000 people continue to live within 40 km of the mountain, with population centers including the 150,000 in Angeles City, and 30,000 at Clark-Freeport Zone. Effects on agriculture: many reforestation projects were destroyed in the eruption, with a total area of 150 km2 valued at 125 million pesos destroyed. Agriculture was heavily disrupted, with 800 km2 of rice-growing farmland destroyed, and almost 800,000 head of livestock and poultry killed, destroying the livelihoods of thousands of farmers. The cost to agriculture of eruption effects was estimated to be 1.5 billion pesos. Many farmers near Pinatubo began growing crops such as peanuts, cassava and sweet potatoes, which are quick ripening and could be harvested before the threat of lahar flows during the late summer rainy season. Local economic and social effects: in total, 364 communities and 2.1 million people were affected by the eruption, with livelihoods and houses being damaged or destroyed. More than 8,000 houses were completely destroyed, and a further 73,000 were damaged. In addition to the severe damage sustained by these communities, roads and communications were damaged or destroyed by pyroclastic flows and lahar throughout the areas surrounding the volcanoes. Total losses in 1991 and 1992 alone were estimated at 10.6 and 1.2 billion pesos respectively, including damage to public infrastructure estimated at 3.8 billion pesos. Education for thousands of children was seriously disrupted by the destruction of schools in the eruption. The eruption of Pinatubo severely hampered the economic development of the surrounding areas. the gross regional domestic product of the Pinatubo area accounted for about 10% of the total Philippine gross domestic product. The GRDP had been growing at 5% annually before the eruption, but fell by more than 3% from 1990 to 1991. In 1991, damage to crops and property was estimated at $374 million, to which continuing lahar flows added a further $69 million in 1992. 42% of the cropland around the volcano was affected by mud flows, dealing a severe blow to the agricultural economy in the region. Lahars. Since the eruption, each heavy rain brought lahars from the mountain range, displacing thousands of people and inflicting extensive damage to buildings and infrastructure costing billions to repair. A large supply of funds was spent in constructing dikes and dams to control the post-eruption lahar flows. Several important river systems stem from Mount Pinatubo, the major rivers being the Abacan, Tarlac, Pasig Potrero, Star, Lucia, Cao, Santo Tomas, Maloma, Tangoy, Ashley, and Kailan rivers. Before the eruption, these river systems were important ecosystems, but the eruption filled many valleys with deep pyroclastic deposits. Since 1991, the rivers have been clogged with sediment, and the valleys have seen frequent lahars which continued for years after the eruption. Studies show that the river systems will take years to recover from the 1991 eruption. Military impact. The United States Air Force initiated a massive airlift effort to evacuate American service members and their families from the two affected bases during and immediately following the eruption, named Operation Fiery Vigil. Most personnel were initially relocated to Guam, Okinawa, and Hawaii, although some returned to the continental United States. Clark Air Base was ultimately abandoned by the United States military, and Subic Bay reverted to Philippine control the next year following the breakdown of lease negotiations. It has been argued that the decrease in U.S. military presence in the neighboring seas following the closure of these two bases led over the following decades to increasingly bold incursions by the Chinese Navy, including the claiming of some disputed islands. Global environmental effects. The powerful eruption of such an enormous volume of lava and ash injected significant quantities of aerosols and dust into the stratosphere. Sulfur dioxide oxidized in the atmosphere to produce a haze of sulfuric acid droplets, which gradually spread throughout the stratosphere over the year following the eruption. The injection of aerosols into the stratosphere is thought to have been the largest since the eruption of Krakatoa in 1883, with a total mass of SO2 of about 17 million AT being injected, the largest volume ever recorded by modern instruments. This very large stratospheric injection resulted in a reduction in the normal amount of sunlight reaching the Earth's surface by roughly 10%. This led to a decrease in Northern Hemisphere average temperatures of 0.5 0.6 AA degrees Celsius and a global fall of about 0.4 AA degrees Celsius. At the same time, the temperature in the stratosphere rose to several degrees higher than normal, due to absorption of radiation by the aerosol. The stratospheric cloud from the eruption persisted in the atmosphere for 3 years after the eruption. While not directly responsible, the eruption may have played a part in the formation of the 1993 storm of the century. The eruption had a significant effect on ozone levels in the atmosphere, causing a large increase in the destruction rate of ozone. Ozone levels at mid-latitudes reached their lowest recorded levels, while in the southern hemisphere winter of 1992, the ozone hole over Antarctica reached its largest ever size until then, with the fastest recorded ozone depletion rates. The eruption of Mount Hudson in Chile in August 1991 also contributed to southern hemisphere ozone destruction, with measurements showing a sharp decrease in ozone levels at the tropopause when the aerosol clouds from Pinatubo and Hudson arrived. Impact on the indigenous people of Pinatubo. The Aetas people were the hardest hit by the eruption. After the areas surrounding the volcano were declared safe, many Aetas returned to their old villages only to find them destroyed by pyroclastic and lahar deposits. Some were able to return to their former way of life, but most moved instead to government-organized resettlement areas. Conditions on these were poor, with each family receiving only small plots of land not ideal for growing crops. Many Aetas found casual labor working for lowland farmers, and overall Aetas society became much more fragmented, and reliant on and integrated with lowland culture. Aftermath of the eruptions in pictures. Activity since 1991. Following the climactic eruption of June 15, 1991, activity at the volcano continued at a much lower level, with continuous ash eruptions lasting until August 1991 and episodic eruptions continuing for another month. Activity then remained low until July 1992 when a new lava dome started growing in the caldera. Volcanologists suspected that further violent eruptions could be possible, and some areas were evacuated. However, the eruption was only minor. And since that episode, the volcano has been quiet. Lake Pinatubo, the 1991 caldera afterwards filled with water from monsoon rains and a crater lake, Lake Pinatubo, was formed. In 1992, a growing lava dome formed an island, which was eventually submerged by the lake. Initially, the lake was hot and highly acidic, with a minimum pH of 2 and a temperature of about 40 degrees Celsius. Subsequent rainfall cooled and diluted the lake, lowering the temperature to 26 degrees Celsius and raising the pH to 5.5 by 2003. The lake deepened by about 1 am per month on average, eventually submerging the lava dome, until September 2001, when fears that the walls of the crater might be unstable prompted the Philippine government to order a controlled draining of the lake. An estimated 9,000 people were once again evacuated from surrounding areas in case a large flood was accidentally triggered. Workers cut a 5 am notch in the crater rim, and successfully drained about a quarter of the lake's volume. Recent activity. On July 26, 2011, a 5.9 magnitude earthquake struck close to Pinatubo, however no major damages or casualties were reported. The western wall of the crater collapsed on July 10, slowly releasing approximately 160 million cubic meters of water and sediments into the Maronot River in Batolan, Zambales. Cultural history. The word Pinatubo could mean fertile place where one can make crops grow, or could mean made to grow, in Tagalog and Sambal, which may suggest a knowledge of its previous eruption in about 1500 AD. There is a local oral tradition suggestive of a folk memory of earlier large eruptions. An ancient legend tells of Bacabaco, a terrible spirit of the sea, who could metamorphose into a huge turtle and throw fire from his mouth. In the legend, when being chased by the spirit hunters, Bacabaco flees to the mountain and digs a great hole in its summit, showering the surrounding land with rock, mud, dust and fire for 3 days, howling so loudly that the earth shakes. History among Aetas. Aetas elders tell many stories about the history of the mountain, the best known being that it was once a batong maybe. It was said to have been planted on a kingdom by a displeased sorcerer but relocated by a hero. The mountain was soon turned into the abode of Apu Namaliari, the pagan deity of the Sambal, Aetas, and Kapampangans living on the Zambales range. It was said to comprise the whole mountain range until Sinukuan of Mount Tarlac became a strong rival of Namaliari. Their fight, which took place over the center plains, shattered the mountain into smaller bodies and Mount Tarlac lost its center peak. Other versions have it that Pinatubo's peak shattered because of Namaliari's immense fury in an attempt to teach humans the meaning of fear and show how misdeeds will be punished. According to the elders, Apu Namaliari caused the 1991 eruption because of displeasure toward illegal loggers and Philippine National Oil Company executives who performed deep exploratory drilling and well testing on the mountain looking for geothermal heat from 1988 to 1990. Discouraging results from the wells forced the abandonment of the prospect 13 months before the April 2, 1991 explosions. Aetas granted ownership of Pinatubo, after being driven away by the 1991 eruption of Mount Pinatubo. In May 2009 some 454 Aetas families in Pampanga were given the first clean ancestral land ownership on Mount Pinatubo with the Certificate of Ancestral Domain title by the National Commission on Indigenous Peoples, the government agency that deals with issues concerning indigenous people of the Philippines. The approved and declared net land area of 7,440.1 ha covers the barangays of Malwakatan and Nabuclod in Floridablanca, Pampanga, plus a portion of San Marcelino, Zambales, and a portion of Barangay Batayon in Subic, Zambales. On January 14, 2010, some 7,000 Aetas families from Zambales were officially granted the Certificate of Ancestral Domain title covering the Zambales side of Pinatubo, which includes the summit and Lake Pinatubo, officially becoming their Lutan Tui. The Ancestral Domain title covers 15,984 ha and includes the villages of Burgos, Villa, Mareza and Belbalimbatolin and portions of the towns of Cabangan, San Felipe and San Marcelino. Having the land title will protect them from others including foreigners from exploiting their land without compensation to the indigenous tribes. In the past, the Aetas had to contend with mining companies, loggers, and, recently, tourist companies who earn from Mount Pinatubo but do not compensate the local tribes. Ancestral domain titles are awarded to a certain community or indigenous group who have occupied or possessed the land continuously in accordance with their customs and traditions since time immemorial. They have the legal right to collectively possess and to enjoy the land and its natural resources to the exclusion of others. Pinatubo in popular culture. Long before Mount Pinatubo became famous for its cataclysmic eruption, Philippine President Ramon Magsaysay, a native of Zambales, named his C-47 presidential plane Mount Pinatubo. The plane crashed in Mount Manangal in Cebu province in 1957, killing the president and 24 others on board. Mount Pinatubo was mentioned in the movie Dante's Peak, when Dr. Harry Dalton, the main character, discovered that the water supply of the city was leached with sulfur. The Star Trek novel The Eugenics Wars has the ozone-destroying eruption of Mount Pinatubo being actually a cover-up to a weapon contained in a satellite launched by Khan Nawanian Singh and his army. Hiking Pinatubo, the caldera formed and Lake Pinatubo has since become a tourist attraction with the preferred route through Barangay Santa Juliana in Capas, Tarlac. See also, active volcanoes in the Philippines, inactive volcanoes in the Philippines, list of volcanic eruptions by death toll, potentially active volcanoes in the Philippines, timetable of major worldwide volcanic eruptions, notes. References. External links. Fire and mud. Eruptions and lahars of Mount Pinatubo, United States Geological Survey site, Mount Pinatubo page. Philippine Institute of Volcanology and Seismology, weather effects of the 1991 eruption EOS volcanology. CVO Pinatubo Photo Archive Cascades Volcano Observatory, the cataclysmic 1991 eruption of Mount Pinatubo, Philippines. United States Geological Survey site.